Here I am going to talk about what is not calibration. Now, what we always my reference is the case study. Replacing suspected faulty equipment, for example, the DTIC with new device is not a calibration. Then suspecting replacing suspected faulty equipment, for example, temperature sensor with a new sensor of the same type is not a calibration. But people say that it is a calibration, but it's really not calibration. Next thing is doing measurement with surrogate instrument and using it as authentic is also not calibration. Now, next is process validation, is used to arrive at working parameters to give optimum performance for consistent results. This is also not calibration, but it gives you the in broad sense the requirements of calibration. Then studying the risk assessment due to malfunctioning or deviation of the equipment out of the specification. This is also not calibration. Studying risk assessment due to malfunctioning or deviating out of the specifications of the equipment is also not calibration. These are the few points which are really not calibration, but these points will make you arrive at the required calibration requirements. Process validation and risk assessment guide you to arrive at process tolerances and of the process tolerances of the instrument specifications and instrument specification. Now, connecting calibrated DTIC and temperature sensor in tandem may not meet your accuracy requirement of the process. That's what we had talked earlier also. Hence, calibration of the whole chain as a black box has to be done for better accuracy. For better accuracy, a correction factor has to be accommodated in whenever you set the temperature set point. This is what was not calibration. Now, what is calibration? Let us discuss it now. Instrument calibration is one of the primary processes used to maintain the accuracy of the equipment. Calibration is a process of configuring an instrument to provide results for a sample within an acceptable range. Eliminating or minimizing factors that cause inaccurate measurements is a fundamental aspect of the instrument design. Although the exact procedure may vary from product to product, the calibration process generally involves use of instruments such as calibrators. The results are used to establish and rationalize relationship between the measuring techniques used for the instrument and the known value. The process in essence teaches the instrument to produce results that are more accurate than those would occur otherwise. The instrument can then provide more accurate results when samples of unknown values are tested in normal usage of the product. This is what is calibration. From a practical standpoint, trade-off must be made between desired level of product performance and the effort associated with accomplishing the calibration. The instrument will provide the best performance when intermediate points provided in the manufacturer's performance specifications are used for calibration. The specified process essentially eliminates or zeroes down the inherent instrument error at these points.